In this lesson, we're going to talk about proving and applying the side angle side and side congruence criteria. So what are these? So first, SAS. This is a side angle side congruence postulate, which says if you have two triangles and two sides in the included angle, very, very important, the included angle. So if you can see here, we have this side, which matches this side. And we have this side that matches this side. The included angle has to be angle B with angle E, right? It has to be the one in between the two sides. If that's the case, like we have here, right? Side, angle, side, then we can say these two triangles are congruent. So we can say triangle ABC is congruent. Now again, order matters. If I do A, we're doing single mark to the angle to double mark. I got to follow the way here. So it can't be F, E, D. That's the wrong way. It has to be the same one. So D, single mark, D, E, F. Right? Order does matter. Like that. So these two triangles are congruent by side, angle, side. That would be the reason. Side, angle, side. And now we prove that these two triangles are congruent. What does that also mean? Well, it means all the corresponding parts must be congruent. Like angle A must be congruent to angle D. AC must be congruent to DF, right? If these two triangles are congruent, all the parts are congruent. We could say all of this is true, right? Angle A, D, like we talked about, C with F, and then AC with DF. So if two triangles are congruent, then all the parts are congruent. Let's do another example. It's a little more weight to this one. So, and here they give us a statement. So given A is the midpoint of DB and A is the midpoint of BC. So with this, we have to understand what that means. Midpoint, right? If A is the midpoint of DB, that means it's right in the middle. So that means that this side must be equal to this side. That's what midpoint means. So I'll put a little mark here, a little mark there. So that must mean that DB is congruent to AB by the definition of a midpoint. Likewise, right, if A is the midpoint of EC, then that means that this side must be equal to this side. So EA must be congruent to AC by the definition of midpoint. Now we're still don't, right? Only thing we know now is side, angle, side. I have side and side. I got two sides congruent, but is this angle congruent? It is, right? This angle here is congruent to this angle here because of vertical angles. Those are vertical angles, right? They're right across from each other. So the last thing I gotta say is angle. Now remember, if you're doing an angle like this, you need three letters. So I could say E, A, D. E, A, D is congruent. Now again, it has to match. So E starts, notice how E has a double mark. So I'm gonna start with the one with the double mark. We're gonna start with C and not B. So we're gonna go C, A, B. So angle C, A, B. Now these two triangles are congruent, right? By side, angle, side. So side, angle, side. So now by side, angle, side, we could say triangle EAD is congruent to triangle CAB. And again, right, once you prove the two triangles are congruent, once you have that, then all the corresponding parts must be congruent. Then ED must equal BC, D goes to B, right? We can say all this is true. Okay, let's do another one. In this congruency statement, SU bisects angle VST, and then SV is congruent to ST. So this is our given stuff. This is stuff we can start off with. So first part, SU bisects VST. So this line here bisects VST. So VST. So this line, this green line bisects this purple line, this purple angle, I should say. So what does bisect mean, right? Bisect means cuts in half. So we're cutting this angle in half. So that means that this side is equal to this side. So that first part here means three letters again, VSU is congruent to, now it's not going to be UST, it's going to be start with the right, same thing, start with the same idea. VSU is going to be TSU. Right, they have to match, so we're starting outside, we have to start on the outside. So VSU, TSU, those two are congruent because it bisects. So definition of angle bisector. Next, so that's it. That's what that means. Next, they just straight out tell us SV is equal to ST. So mark it off. SV is equal to ST. Now, when they just give us a statement like that, we call that given. They just gave it to us. So given. Now, are these two triangles congruent? Not yet. All I got is an angle right here, and we have a side. We're missing still, right? Side angle sides we're trying to look for. Well, this middle one's a special case. Notice how this triangle here and this triangle here both share that green middle line there. We could use that. We call that reflexive. So we're going to say SU is congruent to itself. SU, and we're going to say reflexive. So anytime something's congruent to itself, we call that reflexive. So I'm going to mark it off with a double mark here. Right? They both share that middle line, so that's called reflexive. And there we go. Now we have side angle side. So these congruent by side angle side. We could say triangle. Again, I'm starting on the outside here. Hopefully make a triangle. USV, so to make an actual triangle. VSU is congruent. Start on the outside. TSU. So that's side angle side. If you ever have a side, an angle, and a side, remember the angle has to be in between the two sides, then those two triangles are congruent. So the next one is called side, side, side postulate. Same idea. If I give you two triangles and you can show that all the sides match, then those two triangles are congruent. So it's pretty straightforward. Like if we look at these two triangles here, this side matches with that side, this side matches with that side, and that one with that one. So yeah, these are congruent by side, side, side. And the congruence statement, again, we just gotta make sure it goes in order. So if I say triangle ABC, that's congruent to triangle. Now here, right, A is between the 1 mark and the 3 tick mark, so I want the same one here, so that'll be D. So it'll be DEF. So like that. Okay, let's do an example. This example here. So they're letting us know AD is congruent to BC. So AD is congruent to BC. And AB is congruent to DC. So AB is congruent to DC. So I'm gonna mark it off. I'm gonna do a different marking in this case. Right, so AD goes with BC, AB goes with DC. Again, if they just tell us stuff like that, that's given. Afterwards, we have no more information. So once we're done with all the information they gave us, we have to look at the graph ourselves. If you look at the graph, there's only two things I could really add. That is reflexive if they share a side, or vertical angles. In this case, they both share that middle side. Right? What I mean by this is this triangle up here has DB, and this triangle down here also has the side DB. So those two sides are congruent to each other. So we're going to say DB is congruent to DB. I should put a little hat on. And that's reflexive. Anytime it's congruent to itself, call that reflexive. And there we go. We have side, 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 right? This side's for that side, that with that one, and they share the middle side. So by side, 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 we could say this triangle is congruent to that triangle. Now again, keep in mind, you want to keep the orders important. So you can start off any way you want. You could do ABD, DBA, doesn't matter. I'm going to go alphabetical. ABD. You just got to make sure you match it on this side. So A goes with C. Now what do I go after C? Now again, if I went AB, I went through the double marks. So I got to go through the double marks here. So it'll be CDB. So again, order does matter. So that's like that. Let's do another one. So in this one, they tell us AD is congruent to BC. So AB is congruent to BC. So this side here matches with this side there. That's given. And then they tell us D is the midpoint of AC. So D is the midpoint of AC. So that means that this side is equal to this side, because that's what midpoint means. So I'm going to say AD is congruent to DC. That's the definition of midpoint. Again, so we look at the picture and we're like, okay, well, they're still not congruent. I need side, side, side. I'm missing the side. Well, again, luckily they share this side right here. Right? They both have BD. So we're going to mark that off. We'll say BD is congruent to BD. Anytime it's the same thing, we say reflexive. And now we have side, side, side. So by side, 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 I could say triangle ABD is congruent to triangle Now again, order matters, A, B, D. So A, then I went past the single mark to B. So C must go to B also. So C, B, D. Okay, let's finish off with a few quick fire ones. So all we're gonna do here is determine if these triangles are congruent, yes or no. So remember, all our choices are side, 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 side angle, side, or not congruent. That's all we have. So this is the first one here. Now we have the pair of sides, a pair of sides up here, and they share the middle side. That counts, right? Anytime they share it, it counts. So we have side, side, side. This one over here, we do have a side, and we have a side over here, and then we have an angle. Now, is this side angle side, right? It can't be side, side, side. Just look at the markings, right? This is a side, this is a side, and that's an angle. So side, side, side doesn't make sense. It's either side angle side or not congruent. Now, remember the key thing about side angle side, the angle has to be between the two sides. Look at our two sides here. We have this side, and we have this side. So we're missing the angle in between. So this is actually not congruent, right? It has to be the angle between, very, very important. So if it was this angle, then it would be good, but it's not. There's one over here, right? So same idea. Now I do have a side, and then we have this side that I marked off also. Is that it though? Is it just side, side? Can we say anything else? Well, they share the middle angle also. That's vertical angles. That's one of the two things you could add. They both have the middle angle. So in this case, we actually do have side, angle in between, and then side. So side, angle, side. This one over here, and look at the markings. Do they correlate? So remember, these are just sides. So I'm looking at this, all I see is sides. These marks here mean sides. The little curves mean angles. So this is either side, 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 or it's not congruent. So we have to see if they match, right? So this one goes with this one. So that's a side. This one goes with this one. That's a side. And the last two go together. So that's another side. So we do have side, side, side. Okay, the last few right here. What additional information is needed to prove that triangles are congruent by side, side, side? So I want to make these congruent by side, side, side. Well, right, I have already two sides. I have that one. I have this one. So we're missing the final side. We're missing this bottom part has to be equal to this part right here. We're missing this one congruent to this one. So the congruency statement we're missing is AC is congruent. Now again, order matters. If I'm doing A is between the 1 and the 3. So which one's between the 1 and 3? That would be N. N is between the 1 and the 3. So N has to go first. So AC goes with N. Now that's the third mark. So NM. Right? A and C was the third mark, the 3 marks. So NM was also 3 marks. So that's the congruency statement missing. And then the last one here, if we want to show that this is congruent through side, angle, side, what is missing? So we have a side, and we have an angle. Right, so we're missing another side, but the trick is, what side is it? Is it ED with ST, or is it FD with RS? Now remember, the way we do this with side, angle, side, it has to be the angle in between. So this has to be the in-between angle. So it has to be side FD, which will go with side RS. So the statement should be AD is congruent. Now again, order matters. So we're starting with A, which is by the angle. So it'll be RS. And that's the lesson.